Hi, this is video 2 of the playlist where we've been looking at the June series of exams for Edexcel, and it's June 2018. This particular paper was set on the 24th of May and it's paper 1, which is non-calculator paper. I'm going to be aiming for about 20 to 30 minutes on this particular video. Please do stop the video, have a go at the questions and then compare your solutions. So this is video 2, and with this particular video we're going to be starting at question number 8. Okay, so question number 8, it says the perimeter of a right angle triangle is 72, lengths of the sides and the ratio 3 to 4 to 5. Okay, so work out the area of the triangle. Well, again, there's a couple of ways you can do this. I think from my point of view, what I would say is that if it's 3 to 4 to 5, okay, so you got a right angle triangle here, okay, and that's 3 and that's 4 and that's 5. Okay, well what I need to do is I need to work out that if the actual perimeter is 72 centimeters, what is the actual value of each of these, keeping them in the same ratio. Because if the perimeter was 12, then it would mean that that would be 3 centimeters, that would be 4 centimeters, and that would be 5 centimeters, but it's not 12, it's actually 72. However, what we can say is that it's actually 6 times bigger, so you could work out each of these just by multiplying each of the sides by 6. But if we said that each of those is 3 times x or 4 times x or 5 times x, we're going to get 12x equals 72, so therefore x equals 6. Okay, so it is 6 times bigger, which means that what we've actually got is a triangle which is the shortest side is going to be 3 times 6, which is 18. The side over here is going to be 4 times 6, which is 24, and then the hypotenuse is going to be 30. Okay, so that's still in the same ratio, but now if you add up each of these sides, you're going to get 72 centimeters in total. So to work out the area, well, the area of a triangle is a half base times height. Okay, now I know some people will actually write that as base times height over 2. Doesn't really matter. What we're doing is we're actually got a triangle, if I just stand that up on its end like that, where the hypotenuse is 30, the base here is 18, and then the height is going to be 24. And I could write that the other way around if I wanted to. So I could have a height of 18 and a base of 24. It's still exactly the same triangle. So if I then plug these numbers into my equation here, I've got a base of 18 and a height of 24. And if I multiply those numbers together, I'm going to get 432. And then I multiply by a half, I'm going to get 216. It's a half times 432, and that's going to equal 216 centimeters squared as my answer. Okay, I've just missed out the actual calculation here because I might do it slightly differently to the way that you do it. Okay, but hopefully you'll be okay with that calculation. All right, so let's move on then to question number 9. Question number 9, we're going to be looking at indices. Okay, so it says, firstly, write down the value of 36 to the power of a half. Well, to the power of a half is exactly the same as saying the square root of 36, which is 6. So the answer to this particular one is 6. Then it says write down the value of 23 to the power of 0. Well, 23 or any number to the power of 0 is equal to 1. Okay, and then finally work out the value of 27 to the power of minus 2/3. Oh, right, okay. Well, every time you see a minus sign when it comes to indices, it means the reciprocal. So what we can do is we can write that as 1 over 27. Okay, so that's the reciprocal. The other thing I'm going to do is that hopefully you appreciate that this 2/3 is exactly the same as saying a third times 2. Okay, so I can use that by saying, well, it's the same as 27 to the third squared. Okay, because these two indices are multiplied together and I'm going to get 2/3, and because it's the reciprocal it's minus 2/3. Okay, well, as we worked out in the first part A, to the power of a half is a square root, so actually the power of a third is a cube root. So we're looking at saying that 27 cube root is going to be 3. Okay, and then we're going to square that. Okay, so this 3 is the cube root of 27, and we're going to square it as we did before. So that's going to give us then a value of 1/9, and that would be the answer to this particular question. Okay, hope that's all right for you. Let's have a look then at question number 10. Okay. So question number 10, box plots, very popular with all exam boards actually. So please do a little bit of revision on box plots. Okay, so draw a box plot to represent this information. Okay, well, the least height's 133, so you can actually say that that's going to be around about here. I've got a feeling my drawing won't be as good as yours, but hopefully it'll give you some idea. So the greatest value is 170, so that's going to be over there, okay? And then it says the lower quartile is 145. Well, I've got to find 145 on here, and that's going to be about there, okay? The upper quartile is 157, so that's going to be 155, 157, something like that, okay? And I've got the median value of 151, so that's going to be in here. So what I end up with when I draw the horizontal lines in is a very nice box plot, something like that, okay? And then it says work out an estimate for the number of girls with a height between 133, which is this point here, okay, and 157, which is actually this point here. So what we're looking at is the first part, the first whisker of a box plot is 25%. This interquartile range here is 50%, and then the final whisker is 25%. So actually what we've got within the height range is 75% of the girls in this particular class. Now we know there's 80, so if you go back to actually the beginning sentence, it says the table gives information about the heights of 80 girls. So what we're really being asked to do is to work out 3/4 of 80. Okay, I'm just going to move my paper along a little bit. There we go. So we're going to work out 3/4 of 80, and remember in maths, of generally means multiply, okay? Again, you might do this slightly differently. You might do 3 times 80 is 240, and then 240 divided by 4. That's perfectly fine. I tend to try to do the reduction first, just because it makes my life a little bit easier. I got 3 times 20 is 60. So actually 60 girls have a height of between 133 and 157. Okay, so let's move on then to question number 11. So question number 11, please again do stop the video, have a go at these for yourself. This particular one is working out the size of angle ACB. Okay, so they're actually wanting us to work out this, and the crucial thing here is in terms of x. Okay, all right, so you just need to kind of work through fairly methodically, but it does give you a little bit of information. It says that angle ABO is x. Well, ABO, okay, so AB, and if I put this along here, that means that this will be x. Okay, so the first thing I can write, which they've told us anyway, is that angle ABO equals 90 degrees. Okay, well, ABO as a triangle is actually an isosceles triangle. The reason it's an isosceles triangle is because this length here, which is AO, and this length here, which is BO, is actually the radius of the circle, and they're both the same. Okay, so that's going to mean then that triangle ABO equals an isosceles triangle. Okay, so we are moving ahead a little bit more. Okay, now because it's an isosceles triangle, it also means that angle here, this one here, which is angle OAB, is also going to be x, okay, or x degrees. Oh, realise, ABO, sorry about that, that's x degrees. I do apologise. I don't know why I wrote 90, but angle ABO and angle OAB are both x degrees. Okay, now, again, couple of things that you need to be aware of is that it does say that BC is a tangent to the circle. So if it's a tangent to the circle, it meets the radius at 90 degrees. So in other words, this bit here is 90 degrees. So what we can say is that as BC is a tangent, then right, angle OBC is equal to 90 degrees. Okay, so now we've got this value of this triangle, the large triangle here, which is x. We've got this value, which is also x, and we've got this value, which is 90 degrees. So we can sort of put all of that together. And what we can say is that angles in triangle ACB are going to total 180 degrees. Okay, now I'm going to have to sort of move down the page a little bit here, but hopefully you can refer back to the drawing if you need to. Okay, so we're saying that the total angles in a triangle add up to 180 degrees. So therefore, if we want to work out angle ACB in terms of x, it's going to be 180 degrees minus x. Now this first value of x is going to be OAB, so it's actually going to be this one here. This is OAB, okay? And then it's also going to be minus x plus 90. And this value of x plus 90 is going to be angle ABC. So it's actually, I'll go back to the diagram just so you can have a look. It's actually this angle here where I've added x and 90 together. It's this one. Okay, so we've got now the ability to work out the value of ACB by taking away those two angles. And what we end up with is saying, well, I've got 180 degrees minus x, and then don't forget I've got minus x, and then I've also got so minus x and a minus 90. Okay, be very careful when you remove a minus, or when you move brackets time, you've got to be very careful about the minus sign that's in front of it, so it's minus 90. Okay, so just be very careful about that. So if I now collate this and put this together in a bit more of a sensible way, I've got 180 minus 90, which is going to be 90, and then I've got minus x is minus 2x, and that would be the answer to this particular question. Okay, so we are getting towards the middle of the paper here. It is a little bit more difficult, a bit more challenging. At this stage, if you've scored well on your previous questions, you should be around about a grade 4, and what we're really hoping to do is to start picking up marks now from the rest of the paper to pull that grade up a little bit more if you can. Okay, so let's move on then to question number 12. And in question number 12, we've got some algebra proof. Okay, and it says prove that the square of an odd number is always one more than a multiple of 4. All right. Well, what you could do is for every odd number, you could actually run that through one of these, and you could prove it for maybe 3 or 4 odd numbers before you ran out of time. But actually what they're asking for you to do is to prove it algebraically, prove it for all odd numbers that exist you'll be able to prove it for. And what we normally do with this is that we have a couple of kind of precedents. What we say is that any number is n, and any even number, so an even number, is 2n. Okay, so what that means is that it doesn't matter what the number is, if I multiply it by 2, I'm always going to get an even number. So let's say I've got the number 3. If I multiply that by 2, I'm going to get 6, which is an even number. If I've got 5 times 2, it's going to be 10, also an even number. Or 2 times 2, which is going to be 4, so it's also an even number. So any even number is 2n. So it follows then that any odd number is going to be equal to 2n plus 1, okay? Because if I add 1 to any of these numbers, I'm going to get an odd number. All right, so let's go back to the question. Prove that the square of an odd number is always 1 more than a multiple of 4. Okay, so if I've got an odd number of 2n plus 1, if I'm going to square it, I'm going to write it as 2n plus 1 squared, okay, which is exactly the same as saying 2n plus 1 multiplied by 2n plus 1. Okay, so let's work that out now. Now again, you might use a partitioning method or some sort of grid method of doing this. For me personally, I tend to prefer to multiply out by saying 2n times 2n is 4n squared. 2n times plus 1 is plus 2n. Plus 1 times 2n is also plus 2n, and then plus 1 times plus 1 is plus 1. Okay, so if I tidy that up a little bit, what I end up with is 4n squared plus 4n plus 1. And that's fine, isn't it? Because it allows me then to prove this particular statement, because the first two terms have a factor of 4. Okay, so what we're saying is that as 4 is a factor, then it must be a multiple, Okay, so that's the first point. So that bit of it is a multiple of 4. Okay, the last bit of it is that plus 1 is 1 more. Okay, is 1 more. Okay, so we're proving that the square of an odd number is always 1 more than a multiple of 4. Okay, hope that's all right for you. Please do have a look at some of the playlists within the channel on proving algebraic sequences and algebraic proof. Okay, let's move on then to question number 13. So question number 13 is this surds, and we need to say that it can be written in the form a to root 10, where a is an integer. Find the value of a. All right, so as we did before, what we're going to do is we're going to multiply out each of these brackets. So I've got 5 times root 8, or root 5 times root 8 is the same as saying root 40. And then I've got 5 times root 18, well that's going to be root 90. Okay, so root 40 and root 90 I could write slightly differently, because I can say that this is the same as saying root 4 times root 10, and root 4 is a square number, or rather 4 is a square number, so square root of 4 is actually going to be 2. So I could write that root 40 is 2 root 10. Similarly with this root 90, I've got the same as saying root 9 times root 10, and root 9 is also a square number, or rather 9 is a square number, so that's going to be 3 root 10. So I'm now in a position where I've got 2 root 10 plus 3 root 10, and that's going to be a total of 5 root 10. So in this particular case, the value of a is going to be 5. All right, so we're about 19 minutes into the video, so we'll go on and we'll carry on with question number 14, which deals with direct and indirect inverse proportion. Okay, So y is inversely proportional to d squared. So there's a lot of words for this particular question, and you just need to take it a little bit at a time. So we're going to look at the first part of it, and we're going to work that out. And we're going to say that y is inversely proportional to d squared. Okay, and then it says when d equals 10, y equals 4. Well, that's absolutely fine. So when y equals 4, we've got this situation 10 squared. Okay, well, if we're going to make it an equals sign, that's not true, because 1 over 10 squared is not the same as 4. So what we have is we have this thing here which is called a constant. Okay, constant of proportionality. Okay, and to work out that k value, we do 4 times 10 squared. So in this particular case, k equals 400. So it's more true to write this as a formula of y equals 400, which is the value of k, divided by d squared. Okay, so we've gone from a proportional statement through to something that's kind of working an actual formula. In order to make that formula work, we've worked out the value of k. All right, so we need to do pretty much the same with the second part of this particular question, and it says d is, now this time, directly proportional to x squared. So again, I'm going to write that as a statement. D is proportional to x squared. I need to write that now as a formula, because when x equals 2, d equals 24. So 24 equals 2 squared. Well, no, it doesn't. The bit that's missing is this constant, and we need to again work out this value of k. Okay, so this is going to be k times 4, if you like, 4k. So 24 divided by 4 equals k, and k equals 6. So therefore it's much more accurate for us to write this. In fact, it's true for us to write this as a formula of d equals 6x squared. Okay, so the value of k is 6, and we need to make sure it appears in the formula. So we're now in a position where we've got two formulas. We've got d equals 6x squared, and we've got y equals 400 over d squared. And it asks us to find the formula for y in terms of x. All right, so what they're asking us to do is to take this value of y equals 400 over d squared, and rather than writing d squared, we're going to take this value here and we're going to substitute it into there. Now remember, this is the value of d. It's not the value of d squared. So we've got to write this as y equals 400 over 6x squared, which is the value of d, and that itself is actually squared. Okay, and I know this is a 5-mark question. I think the reason it's a 5-mark question is because you might miss that square out, but it is the value of d squared. Okay, and this is where brackets really do become very useful. Okay, so we can now work that out a little bit better. We can write that as y equals 400. Okay, so each of these terms need to be squared. So 6 squared is going to be 36. And x squared squared is going to be x to the value of 4. So it's 36x to the value of 4. I think that's probably good enough for this particular question. It is a 5-mark question. For me personally, because I know that I can reduce this fraction a little bit, I would probably err a bit on the side of caution, and I would divide top and bottom by 4, because if I did that, I could write that as y equals 100 over 9x to the 4. Now just notice on the question it does ask you to give it in its simplest form, which assumingly means that there is a mark awarded for this divide by 4 towards the end. Okay, so that's 25 minutes into the video, so I think we'll stop there. We'll move on then from question number 15 in the next video, which is going to be video number 3. I hope it's been useful. Please do add any comments below, and I'll look forward to seeing you inside the next video.